gotta love it. All right, so we're finding the arc length. They give us a closed interval for t, 0 to 1. So dx dt, pretty easy. It's just a little power rule. dy dt, same deal, just power rule. 12t squared. I promise I won't say everything's easy. Only the things that are. Those should be easy. So the arc length going to be on 0 to 1, the square root of 2t squared plus 12t squared dt. All right, because it's dx dt squared plus dy dt squared. Four t squared plus 36. Jeez. Now I'm all like discombobulated because of the whole recording mishap. 144 t to the 4th dt. This is what I was talking about. So you get to something like this and you say, well, I had a good run. So better drop the course because I can't. No, don't drop the course. I'm crying out loud. Jeez. It's a definite integral. My rule of thumb with definite integrals is it's the calculator and that's it. You could be impressed with your knowledge of all sorts of antiderivative techniques, but if it's a definite integral, I do not need to see any work other than the answer. All right, and in fact, in most cases, the biggest challenge is not going to be the integration process. The biggest challenge is going to be coming up with the integral that you would need to integrate. Right, just thinking in terms of volumes from Calc 2. Like once you had the integral, you didn't have a problem with it. It was getting to the integral, that was the issue. All right, that's the same idea here. So the question is going to be, well, how do you do that? I'll show you in a sec. All right. Sometimes it involves going back and forth between the different modes on your calculator. All right, this is a function of a single variable, which is fine if you're in function mode. It can get a little funky if you're not. All right, so if you're familiar with the, and I already mentioned this, when you're dealing with parametric form, if you're in the calculate menu, it doesn't give you anything related to antiderivatives, so don't even bother looking at it. But if you go to math, the math menu, which is, I say the same joke every class, it's not even really a joke, it's just surprising. You think the whole calculator would be a math menu, but one dedicated math menu. You got to scroll down a little bit, but eventually you get to the calculus stuff. Well, Fmin and Fmax are both calculus things too, but what you're looking for is function integral, which is math option 9, Fn integral. Honestly, I don't know if that even stands for function integral. I think it does, I assume it does, but it doesn't really matter. It's the one that gives you integral stuff when you click it. All right? And so it really doesn't matter what variable you're using in your integrand as long as the argument is the same. So if I want to use t's, r's, q's, doesn't matter as long as there's no disagreement between these two fields. So all I'm doing is typing in the 0, the 1, popping in the root of 4t squared plus 144. You can use x if you want, it doesn't matter, because the calculator is going to know what you're talking about as long as you tell it what you're talking about. And the way you tell it is by indicating what the variable is after the d. And it should be pretty user-friendly because unless you have a TI-83, I don't see any at first glance, but the TI-83 comes up completely differently. But the TI-84, when you hit the integral function, it brings up something that looks very much like the problem that you're working on. So it's just a matter of making your calculator match what you wrote down on paper. With the TI-83, it's a little bit of a different story. You got to work around it. It's doable, but not as user friendly. Okay, so hit enter, and you have your arc line. So scary just got less scary, hopefully.
We just leave it in that decimal form, or would you like us to try to get into fraction form? Or?
No, I don't have any particular desires as it applies to that. And a question might ask you to round a particular way. The only time I ever do that is just so I can eyeball it quicker when I'm grading. But I mean, like when you start getting to like the statistical implications of these things, you generally want to go to 3 significant digits if you're looking for the most accuracy without sacrificing efficiency. 3 significant digits gets the job done. But anything more than that, you're just kind of wasting your time.
Yeah, I got 30.1 through 50.
Crikey. All right, well, let me double check mine first because I usually am the one to screw it up. You got mine? Oh. You just got a 4? Okay, if you just got a 4, there's a quick fix to that. Go to mode and make sure it's on float because it's over rounding. Let me see. Oh, because you're in parametric mode, it's going to keep it as T. If you want to call it X, you have to use that. All right, so this would be some sort of linear units, 4.1 miles, whatever.
How would you solve this without using that?
Oh, well, the first thing you would do would be to factor out a GCF and pull it out of the radical. And then after that, you'd use some sort of trig substitution method. The short answer is it would be a nightmare. So that's the other reason why we use the
Just
calc.
sketch off the square root, the t squared before, it's just all squares, and then once you do the...
That would bring a t out, but then you still have a 4 plus 144t squared. Oh, so it would be just u substitution. So it's not as nightmarish, but you'd still have to use u sub. Because your inner function would have a derivative of 288t, I think. So, more trouble than it's worth. That's really the moral of the story. And besides, you get to the ones involving trig functions, and it gets even crazier. Speaking of crazy, I should start you off on this one because this one actually gets a little too crazy. So I was gonna put a star on that one for you, but yeah, which you won't have to bother with because it's a definite integral. So it's nice. So dx dt. Now we have a product of 2 functions, so we do have that road to cross. So we have to use a product rule. First times the derivative of the second plus the second times the derivative of the first. And then the same for the y's. All right, so we're looking for s equals, I might as well, just do one of these. I mean, I don't want to oversell it. I mean, if you distribute it out and combine like terms, clean it up a little bit, it does get a little nicer. But that would require you to simplify it by distributing it out, combining like terms and cleaning it up before you even bothered with any of the calculus stuff. I mean, it's not really the focus of the course. I mean, I don't want to do that. And I don't want you to have to do that. It's just, I mean, I've gone both ways before where it's like, all right, you got to do the integration part by hand and show all the work and everything. And it's like, as I'm grading the papers, I'm like, why am I doing this? Like, they demonstrated all the Calc 3 knowledge. The only thing that they got bogged down on is the Calc 2 stuff. And, you know, I guess there's a time and place for that, but to hit you too hard too early with that, it doesn't seem reasonable. But you were already convinced before I started talking about that, so I don't know why I'm still talking about that. You would just put all this stuff in your calculator, though, and so in the end, you'd be like, wow, this is such a pain. And, you know, that's the thing. You get used to things, the finer things in life. And so what'll happen is inevitably, you know, because humans like to complain, it's like, I'll never understand humans. Once I get a handle on the human race, I'll be fine. But then I can go home. So what happens is you get comfortable with an idea, and then you start complaining about the thing that you're comfortable with. So eventually it becomes, oh, I got to type in all this stuff without ever having your eye on the fact that, yeah, I have to type in all that crap because I don't have to do it all by hand, right? So rejoice in the fact that you have to type in all this crap, all right? That's an important thing to understand. Just think about every teacher that made you do all this crap by hand. Okay, so maybe not every. Just one. Most of my students would agree, I think, I don't think I'm making stuff up, that I get you to demonstrate the knowledge even while using the calculator. Like, you still have to demonstrate that you understand calculus, but the calculator is a support, and I don't see why that should change. All right, so if that ever changed here, then I would change being here. Like, I wouldn't be here anymore. So, by choice.
That's how you do the math to the calculator itself.
You can't, like, you got to get to this step. Like, you got to do something. What's that? Am I going to what? Nah, I'm going to leave you in suspense. Like, what's going to happen? Watch it say error. Oh, look at that. That's anticlimactic.
I think it got answered.
Every time, it's like it's a proportional relationship. When I go on like a little spiel talking about how great the calculator is, it almost always produces an error message, so that I have to look everybody in the eye and say, well, except for that one time, like, you still got to know it apparently. So I was waiting for that to happen. Yeah, I mean, the calculator, I mean, it will fail you sometimes just because of domain considerations, so you got to be careful about that. But aside from that, it's a good resource. Use it.